You are miles into the field, ready to take crucial soil readings, and your digital sensor flashes the one thing you never want to see: low battery. What if I told you the most scientifically accurate, reliable soil meter for your toughest jobs doesn't use batteries, doesn't need calibration liquids, and actually outlasts the latest digital technology? Today, we are breaking down the science of battery-free meters. Welcome back to Certified MTP. If you work in agriculture, agronomy, landscaping, or material testing, you know that accurate soil pH and moisture readings are the absolute foundation of everything you do. For years, the industry has pushed digital sensors. They look sleek, they have bright LCD screens, and they promise instant, effortless results. But there is a hidden cost to all that digital technology. Let's talk about the exact limitations of digital glass electrodes. A glass electrode requires a reference liquid to complete its circuit. This means you are constantly dealing with delicate glass membranes that must be kept wet. If they dry out, they degrade. If you test in abrasive soils, the glass can easily scratch or break, instantly ruining an expensive piece of equipment. On top of that, to ensure accuracy, a digital meter requires frequent calibration using specific buffer solutions. You have to carry these liquids into the field, carefully dip the probe, adjust the software, rinse it, and only then can you take your actual reading. It is a tedious, multi-step process. And most importantly, they rely on power. When you are out in the field, a dead battery means dead productivity. But science gave us a solution to this decades ago, a solution that is preferred by professionals who need rugged, on-the-spot reliability. I am talking about galvanic cell technology, utilized brilliantly in high-end analog meters. In this video, we are going to look closely at how a battery-free meter actually outperforms its digital counterparts in field conditions. And specifically, we are going to walk through a simple, step-by-step explanation of how to use two of the absolute best in the business: the Kellway Soil pH Acidity Meter and its big brother, the Kellway Soil Acidity and Moisture Meter. Before we look at the physical products, you have to understand the science. How does a device measure pH or moisture without a power source? It comes down to basic chemistry and physics. These Kellway meters utilize two dissimilar metal plates or rings on their lower housing. When you insert these dissimilar metals into moist soil, the soil itself acts as an electrolyte. The chemical reaction between the moist soil and the two different metals generates a very tiny, completely safe flow of electrical current. This is known as a bimetallic potential. The meter doesn't need a battery because the soil becomes the battery. The device is simply reading the electrical potential that is naturally generated by the earth. Why does this matter? Because pH is the measure of the degree of acidity or alkalinity of the soil. The lower numbers are acid, the higher numbers are alkaline, and 7.0 is neutral. The nutrients that support plant growth usually cannot dissolve in soil moisture that is extremely acidic or alkaline. Because the Kellway meter's reading is based on this direct, fundamental electrical potential, there is no digital processor to get confused, no software to glitch, and no glass node to shatter. It is pure, raw, scientific accuracy. However, because the current is so incredibly small, the metal plates must be perfectly clean, and the soil must have excellent contact with the housing. That is the only trade-off. You trade the massive hassle of batteries and fragile glass for the simple requirement of keeping your instrument clean. Let's look at exactly how to do that with our first piece of equipment. This is the Kellway Soil pH Acidity Meter. It is handheld, exceptionally durable, and designed specifically for fast, accurate pH measurements in the field. It has a pH range of 3 to 8, which covers almost all standard testing scenarios, and it is accurate to plus or minus 0.2 pH. If you are a landscaper, a serious gardener, or a field technician, this is your everyday carry. So how do you use it? The process is incredibly simple, but you must follow these steps precisely to guarantee that scientific accuracy. Step 1 is the most critical. Clean the metal rings. Because the electrical current is so tiny, even the natural oils from your fingerprints can disrupt the flow and ruin the reading. You will take the Kellway conditioning film, which comes included with the meter, wrap it around the two silver rings, and gently rotate the tester back and forth 2 or 3 times. After that, wipe the rings completely clean with a paper towel or soft rag. Do not skip this step and never use regular sandpaper. Only use the specialized conditioning film. Step 2, Prepare the soil. Remember the science we just talked about? This meter requires moisture to act as an electrolyte and create the electrical current. If the soil is bone dry, no current can flow, and the meter will not work. If the ground is dry, pour a little distilled water on the area and wait about an hour or two. Once damp, soften the soil and carefully remove any pebbles, grass, or leaves. You want pure, soft, consistent soil. Step 3. Gently insert the tester vertically into the softened soil until the metal rings are fully covered. Press the earth tightly around the tester. You need maximum surface contact between the soil and the metal rings. Now look at the dial. When you first insert it, the needle will likely swing all the way to the right. Do not panic, just give it a moment. Within 2 to 3 minutes, the needle will drop and stabilize at the correct pH reading. That is it. No buttons to press, no calibration fluids to mix. Just clean it, insert it, and read it. Once you are done, wipe it down, and it is ready for the next 100 tests. Now, what if you need more data? What if you are an agronomist, a facility manager, or a serious testing professional who needs to know both the acidity and the exact relative moisture saturation of the soil? For that, we step up to the Kellway model HB2 soil acidity and moisture meter. This is a professional-grade unit made in Japan, renowned for its lifelong reliability and craftsmanship. It uses the exact same battery-free, bimetallic potential science we just discussed, but it utilizes a larger cone-shaped end with 2 large dissimilar metal plates instead of rings. This larger surface area, combined with advanced internal circuitry, allows it to measure soil pH in the 3.5 to 8.0 range and moisture from 0 to 100% relative saturation. Let's dive a little deeper into that moisture reading capability. Why is relative moisture saturation so important? In agriculture and construction, moisture dictates everything from irrigation schedules to soil compaction rates. The HB2 doesn't just tell you if the dirt is wet or dry, it gives you a scientific percentage based on the electrical resistance of the soil. For example, a sandy loam might hit its field capacity, meaning it is holding all the water it possibly can at around 45% on the dial. A heavy clay soil, on the other hand, might hold 65% before it is completely saturated. By understanding the specific type of soil you are working with, the HB2 allows you to precisely dial in your moisture levels. The workflow for the HB2 is very similar to the PhD meter, but there is a specific order of operations. Let's walk through the simple explanation of how to use it. Just like before, step 1 is conditioning. Using the Kellway conditioning film, rub the large metal plates on the cone tip completely clean. Wipe away any metallic dust with a paper towel. The plates must be chemically clean. Step 2, soften the soil, remove the debris, and ensure it is damp. Insert the cone-shaped end into the ground so the metal plates are fully submerged. Pack the dirt firmly around the cone. Good soil contact is absolutely non-negotiable for accurate dual readings. Step 3. By default, the HB2 is set to read pH. You do not need to press anything. Just wait 2 to 3 minutes for the needle to stabilize on the upper scale. It will swing, then settle on your highly accurate pH reading. Step 4. To read the moisture, simply press and hold the button on the side of the housing. Keep it depressed. You will need to wait another 2 to 3 minutes for the internal resistance to stabilize. The needle will drop to the lower scale, giving you the percent relative saturation of the soil. When you are finished, release the button, pull the unit out, and thoroughly wipe the plates clean. It is a masterpiece of analog engineering. It does the job of 2 delicate digital meters without a single battery, entirely eliminating downtime in the field. If you are ready to upgrade your testing toolkit and leave the dead batteries behind, you need these Kellway meters in your arsenal. We have both the Kellway Soil PhD Acidity Meter and the dual-purpose HB2 in stock and ready to ship. Click the link in the description below to visit certifiedmtp.com and secure yours today. If you found this scientific breakdown helpful, make sure to hit that like button, subscribe to the channel for more deep dives into industry-leading testing equipment, and let us know in the comments what gear you want us to review next. Thanks for watching, and we'll see you in the field.